Welcome, everyone. Welcome. Thanks for having me on the show today. My name is Sebastian. I'm working as a solution architect for a Germany-based company. It's called Quibic. Quibic's focus is doing integration projects using BizTalk, AIS, or SAP Integration Suite. And today, I want to talk about the seamless SAP integration with Azure Logic Apps. What I want to show you today, just a quick overview. First, I want to show you the importance of SAP integration. Then I want to show you which SAP versions you can use to integrate with your Logic apps. Then I want to show you which Logic apps deployment model supports the SAP integration. After that, I will come to the SAP connector. SAP connector is a prerequisite which implements the protocol to access the SAP. Then we will come to authentication. Then I will show you some scenarios. And at the end, I will show you a little demo where we see everything in action. Let's go. So why SAP integration is important. 77% of the global transaction runs over SAP systems. 86% of the Fortune 500 companies are using SAP systems. And 98% of the top 100 brands are using SAP systems. As you can see, these are remarkable facts. And so this leads us that SAP is a leading provider of enterprise resource planning software. And therefore, integration platforms needs the capabilities for SAP enterprise integration to be successful. And therefore, Logic Apps is an integration platform you can use to integrate your SAP systems. And this leads us to this next slide here. When you want to start your SAP integration journey, you need one of these supported versions that you can use with Logic Apps. You can use on-premises and cloud-based HANA-based SAP systems, such as S/4HANA, but you can also use the classic on-premises subsystems, such as the R3 system or the ECC system. So if you have one of these supported versions, you are able to start your journey of integrating your subsystems using Logic Apps. And to start, you need the right Logic Apps deployment model. And in this case, the Logic Apps consumption on the left side, and also Logic Apps standard deployment model supports the integration of the mentioned SAP systems before. So in the middle, you can see we have the S/4HANA system, cloud-based or on-premise, the R3 system, or the ECC system. And as you can see, you can run the SAP systems in a public cloud, in a private cloud, or in an on-premise private environment. So when you want to use Logic Apps consumption to integrate your SAP workflows, you need to use the Manage connector to connect to SAP. So in this case, you are on a multi-tenancy mode to integrate SAP. And if you want to use the SAP, in many cases, the SAP system is in a private network, so it's not in a public network. You need to use the on-premises data gateway to connect to the SAP system in these private networks. I prepared a slide for this. If you don't know what the on-premises data gateway is, as you can see on the left side, we have the Logic Apps consumption deployment model here. We have our workflows. And if we want to connect to our SAP systems, you can see at the top here, it's the S/4HANA, R3, or ECC. We need to install the on-premises data gateway in the near of this SAP systems. In the near means when we install the on-premises data gateway, which is a software which comes from Microsoft, you need to install it in a network where you can reach the SAP systems. So that means on-premises data gateway needs to be installed on a server which is near or in the same network of the SAP systems, then when it is in the near, you need to ensure that the on-premise data gateway can reach the SAP system in your networks. And the communication is based on relay services. That means logic apps consumption will place a message inside of the relay, and the on-premises data gateway will subscribe to these messages and will then execute the command inside of the message inside of the relay here. So this is the communication between your logic apps consumption and your subsystems. If you want to use the logic apps standard deployment model, you can use the built-in connector to connect to SAP. In this case, you are in a single tenant mode, and there are a lot of advantages to use this built-in connector. Maybe there's or a larger limit size of message size over 100 MB, and a lot of other advantages here when you use the built-in connector. And another thing here is you do not need to use the on-premise data gateway. You can use the VNet integration capabilities to connect to your SAP system in private networks. I also prepared a slide for this. So this is the VNet integration slide here. As you can see, the supported systems, the S/4HANA, R3, or ECC, are placed in the public cloud, private cloud, or on-prem environment. But in this case, the logic apps standard are also deployed in a virtual network. And the main thing here is that we need a peering between the virtual network where the logic app standard is deployed and where your SAP systems are living. So if you have this peering, then logic app standard is able to connect to your SAP systems, and also your SAP systems, we will see that in the scenarios later on, your SAP systems are able to connect to the logic apps standard. So to use one of those deployment models and one of those connection models, we need some prerequisites. And this prerequisite is the SAP connector, which is maintained by SAP itself. Right now, we have the version 3.1. It's called the NCO connector. NCO are libraries, and these libraries for Logic App Standard, for example, are part of the workflows. We will see in a minute what that means. And the subconnector for the Logic App consumption model needs to be installed on the OPDG nodes. I've also prepared a slide for this to make that a little bit clearer. And I also have a link here if you want to have a look on the documentation for this subconnector. So as I said, the subconnector in Logic App Standard will be included in your workflow app. That means, as you can see on the screen here, as an artifact under assemblies, we need to provide these libraries, and then the workflows can make a connection to the SAP system using these libraries. If we want to use the subconnector in the Logic Apps consumption deployment model, it's a little bit different. As you remember from the slides before, for the Logic Apps consumption, we need the on-premises data gateway installed on the server in the near of the SAP systems. And the special thing with an on-premise data gateway is that you can run the on-premises data gateway in a cluster. So that means you have multiple nodes with the on-premise data gateway installed. And to connect now from a Logic Apps consumption to your SAP system, you need to install the subconnector on every OPDG node. That's the meaning of this little bubble here. So that's very important to install the connector on every OPDG node. So when we have the prerequisites, the next thing we need to think about is authentication against our SAP system. I don't know any subsystem which is open to public, so we need to authenticate against SAP. There are two methods we can use from Logic Apps. First one is the basic authentication. And with basic authentication, we only need to provide a username and a password. And a more secure one is the SNC connection, which is the secure network connection. And this connection uses an X509 certificate, and the encryption and decryption will be done by a private and by a public key. So the SNC connection is more secure than the basic connection. So we have talked about the prerequisites, and we already know how to authenticate against the SAP system. Now we want to have some scenarios with logic apps. And we have we have two main scenarios. First scenario is receive messages from SAP, and the second one is send messages to SAP. Let's start. Or firstly, not start. With receive and send, we can use this communication types here. The first one is the RFC. This is a remote function call. The second one is a TRFC, which is a transactional remote function call. The third communication type is BAPI, which is the business application programming interface. And the last one is the IDOC, which is the intermediate document, which is a flat file or an XML file. All the other communication types are mainly XML based, but can have a look later what that means. There are also some approaches when it comes to receive messages from SAP systems. The first one is an RFC-based approach. The second one is an API-based approach. And the third one is an event-driven approach. And on the next slides, I want to show you more details of these approaches. The first one is receive messages. In this case, it's an RFC-based logic apps consumption. So this is the RFC-based approach with logic apps consumption deployment model. As you can see, we have our SAP system on the left, and we need to use the on-premise data gateway in this case as well. So receive messages means we want to receive messages in our logic app consumption from SAP. This is the direction. Receive messages means we want to receive messages in logic apps consumption here. And what we need to do is here, we need to configure a trigger when a message is received. And this trigger is an RFC destination in our SAP system. That means we have a program ID here, and the program ID is, as you want, the subscriber to data which comes to this RFC destination. And the data flow, well, when SAP sends data over this RFC destination here, it needs to go through the on-premises data gateway, because the way back to the logic apps is exactly the same as we want to connect or send data to SAP. When we are talking about logic apps consumption, we need to have this on-premise data gateway in place, and it's exactly the same. Then there's a relay which is used to send the data to our message trigger here. It's a little bit different when it comes to the RFC-based approach in Logic App Standard. Here's the case. We have this VNet peering in place. So this is a VNet integration here. And then we can have a direct connection from the subsystem via an RFC destination to our Logic App workflow, which is hosted in a Logic App Standard workflow or in a Logic App Standard app. Trigger is the same when a message is received. There's also a program ID and so on. And over this program ID, the RFC destination is connected. And as you can see, this is not that complex with this or as the approach with the on-premise data gateway, because much less components are active in this approach here with Logic App Standard. Then we can also have a receive messages scenario which is API based. And in this case, SAP is using an HTTP destination instead of an RFC destination. And then we can have, this is optional, we can have an API management in between our logic app and the SAP system. And in the API management, we have exposed an API, and the data which comes through this HTTP destination is then forwarded from the API management to our logic app, where we have the when a HTTP request is received trigger. So that means this logic app is HTTP enabled, and we can expose our logic app inside of the API management. And this approach is for logic apps consumption and for logic app standard exactly the same. That's the reason why we only have logic apps here. And the third one is the event-driven based approach. And the event-driven based approach is the following. SAP sends, or in our SAP system, there's an event created. In this case, it's called sales order created. That's our event. That means that SAP is our event source. And via the SAP event mesh, which lives on the BTP, the event sales order created will be published to our event grid partner topic. So that means event grid is our event broker here. The special thing here is that SAP is a third party, or a third party partner topic, which you can directly span inside of the Azure portal. So you can create an event grid partner topic, and you can connect your SAP or the event mesh directly. So you can couple it together inside of this configuration. And inside of this event grid, you can have a webhook to the logic app, which is the when an HTTP request is received trigger. So that means that our logic app is the event subscriber in this case. And that's exactly the same for logic app consumption and also for logic apps standard. So now we talked about the receive messages scenarios, but we can also send messages to our SAP system. And we can, as you seen on the previous slides, where we are talking about this communication protocols, you saw we can use RFC to call or call a function in SAP. It can be a system function, or it can be a custom function called to the subsystem. On the other side, we can send IDOCs. We can also receive IDOCs, but now we are in the send scenarios. You can send an IDOC directly to the SAP system. And an example is here. You have an order, it's an orders 05, and you can use this orders 05 to send it directly to the SAP system. And the last thing here, you can also send a BAPI, and with a BAPI, you can call a method in SAP. And that's also what we want to do in the demo right now. And in this case, you can call a BAPI that create a sales order. So this is the send message scenarios, and these send message scenarios are the same for logic apps consumption and also for the logic apps standard, with this specific communication patterns to use with OPDG or with a VNet integration. So to show you this live and running, I created a little demo, and I want to show you the Azure portal, want to show you Visual Studio Code, and I want to also show you the result in the SAP system. Let me explain our demo scenario here. We have an S/4HANA system, which is provisioned on Azure in its own VNet. We have our logic app standard, workflow, which is also created in an own VNet. And both VNets are peered to each other so that the systems can communicate with each other. So this is very important part here, the peering. Our logic app standard has an HTTP trigger. So that means when an HTTP request is received, then our logic app or the workflow especially will then be executed. And we have a business partner that sends us an sales order, and this sales order will be sent by post over HTTP, and the body of the message, which will be sent to our workflow here. This is the sales order from our business partner, and it's an XML. So this is the scenario, and this I want to show you, and therefore I switch over to the Azure portal right now. Let me start with the prerequisites. So we are in Logic App Standard here. That means the subconnector needs to be as a part of the artifacts here. And as you can see here under assemblies, I've provided the necessary libraries. You can see it from the documentation, which libraries are needed. So this is the first prerequisite here. Then we will have some schemas. We'll show you that here. These are also some artifacts. I can go up here. That means we have a request XSD schema. So the request XSD is what our business partner will send us. And then we also need the BAPI structure. So that means we are able to generate a schema from SAP. And then you can say you want to have this bus 2032 sales order schema. And then you can download the schema directly from SAP. And then you can upload this schema here in your artifacts, and especially here in the schemas. And then we need to solve one problem because the request and the BAPI are not the same. So we need some kind of transformation. And for this, we have a map here, which executes this transformation. So that map is called map request to sales order BAPI. I will show you in a minute in Visual Studio Code how to do this with a data mapper. But for now, these are the prerequisites we need. And now let's go over to our workflow here. So as I said, our workflow here has an HTTP trigger, and the only method allowed here is post. That means the business partner can only use post to send data to us. In the first step, we want to validate the XML payload coming from the business partner. So that means we are using the body. So this is the payload from the HTTP request, and we want to check it against our request schema. So you have a drop-down with all your artifacts, and then you can select the artifact you want to check here. In this case, this is the request coming from the business partner. And if the XML is mail-formed or the XML is not valid, then we send back a bad request response to our business partner, and with the error message that your XML is not valid. I show you in a minute how that works here. If the XML is valid, then we go here, and then we have this transform XML scope. So as I said, we need to transform the request to our BAPI request. That means in this transform XML, we are using the content. So this is the payload, which from the HTTP request. And then we are calling this map here, which is also an artifact I showed before. This is also a dropdown. If you have multiple maps, you can select the map you need to have here. And after the transformation, we want to do also an XML validation for our BAPI. Exactly the same as you've seen above for the request. We can do it with now the validation with our schema for the BAPI. So, and if this is successful here, we have then the SAP scope. And in the SAP scope, we need to create a stateful session. So here we do not need any other options. I also created a connection here to my S/4HANA system. We can change the connection here. We can also create a new one. And you have seen this here for the demo purpose here. You can set a connection name. Then you need to specify the client. Then you need to specify if you want to use basic authentication or you want to use the logon using SNC, so secure network connection. In this case, it's basic. So then you need to specify the SAP username, your SAP password, the logon type, then the address of your application server from SAP, the service, and the system number. And that's it. And then the logic app uses the subconnector, as I said before, and then it creates a channel to communicate with the SAP system. But for now, we have this connection in place, so we will use it. Well, as I said, for the BAPI, we need a stateful session because we need to transmit or we need to commit the BAPI when it is inside of SAP. But we will see in a minute here. So after we create a stateful session, we can perform our BAPI call. The BAPI call is the we can use the BAPI action, and then we specify that we want to send this specific business object here, which is the bus 2032 sales order. And then you can say we want to perform this method here, sales order, create sales order. And what we need to specify here is our BAPI XML, which is the representation of the schema which is used to call the BAPI method here. And this is the output from our transformed XML output from here. This is the transform XML result. And if our BAPI call is successful, we can commit the transaction. So this is the reason why we need this stateful session here. And because we want to commit the transaction inside of this session ID, which comes back from the create stateful session. If we have an error during our BAPI call, we need to roll back the transaction. So we need to specify a ran after. So that means BAPI call has failed. Then we can have the exception handling here. And inside of our exception handling, we can roll back the transaction. It's exactly the same. We only roll back the current open session. And if the BAPI call is successful, we can send a successful response. And in this response, we only say your order was stored successfully. And we also extracting the order number from the BAPI response to send it back to our business partner. If there are any questions or something else, then the business partner has an order reference for the sended order. And that's all in our case here. And so now let's jump over to Visual Studio Code. As you can see here, this is the project inside of Visual Studio Code. So here you can use Azure Portal or as well VS Code to create your workflows. And then when you're using VS Code, then you can deploy it directly to the portal. Right now, as you can see here, we have the schemas here, the BAPI schema, the request schema, and also a type schema, which is used from the BAPI schema here. And I also told you that we need a transformation. And for this, you can use the data mapper. And inside of the data mapper, let's show you here, you can specify a source schema and you can specify your destination schema. And then you can use drag and drop to connect the nodes from the source to the destination. And if you finished it, you can generate an XSLT from your map here, and you can also run a test directly from here. So we can do it here. So this is our request, which comes from the business partner. And then you can click on test. And then you can see the output directly in the window here. And this is the BAPI call we want to send to the SAP system. So this is just a quick look on the data mapper here. Right now, I want to perform a request. So now we are using the REST client inside of VS Code here. This is the endpoint to our logic app with the HTTP trigger you've seen before. Then we need to specify the content type of the payload, which is application XML. So right now we are simulating the business partner. So I am the business partner right now, and I want to order the following, which you can see in this sales order XML here. So for the quantity, I change from 10 to 12. And for the first, I want to have a non-valid XML. So I will remove the bracket here. So this is a non-valid XML, and then we can send the request. And as you can see, your XML is not valid. So it's the XML validation state or the XML validation action, which turns into an error. And therefore, we are using the first exit here. Let me show portal. Exactly the first exit here because the XML is not valid. Now let's fix this. So positions and send it again. Send request. So now we should have a successful response. And as you can see, your order was stored successfully. And we also got this order reference I said before. Now we can use this order reference. It's 5669 and go to our SAP system. So I will switch to the SAP system right now. So now this is the SAP system. And here I go to the transaction VA03, which shows all sales documents. And now I can use this 5669, which is the order reference. Hit enter. And now you can see this is exactly the sales order I sent to the SAP system via the logic app. So this is the order quantity 12. I changed this from 10 to 12. The delivery date is today's date, but nevertheless, you can see the data is inside of the SAP system here. So let's switch back again to the Azure portal, because I want to show you how you can debug or how you can view failed runs or successful runs. So therefore, you go to your workflow, and then you can click Overview. And inside of Overview, you can need to zoom out. And as you can see, we have one failed and one succeeded. Let's click on this failed. And the expectation here is that the failed has gone the way with a bad request. As you can see, the error message is invalid template. And you can see our logic app is gone on send bad request response. So this is the reason why it is on failed. And the other one, which is the succeeded one, also have a look. Here you can see everything is green. And you can see where the flow was going. And you can also see the elapsed time on a specific action here. And to find, for example, bottlenecks or something else. And then you can see we have a success response here. Yeah, that's the demo with Logic App Standard. Let's go back to our presentation. Yeah, That's seamless SAP integration with Azure Logic Apps. And feel free to ask any questions. Please use the chat for this. We can, or please, let's connect on LinkedIn. You can see the URL here. And if you want, you can also join the Aviators Germany community, which is a branch of the Logic Apps community.